So understanding NAT so that we will understand how to configure. How to configure is easy, but what happens really behind the screen on the CLI, sorry, on the GUI when we do it on the FMC, the things that are happening behind, we need to understand that. So we are here. We see that the objects, it's the same object you will also create in FMC. We create objects to do this netting. That's why it is called object-based net. And there is also one more called manual net. We'll see both. When you don't use object, then it is manual net. There are three types here we see. Manual net will be seen as a section 1 on the command line. Auto net as a section 2. After auto, manual net is section 3. This is also manual net, but it is called as after. There is a command called after auto. When you put this one, then the manual net comes below auto net. Have you worked on CLI of ASA?
Yes, sir, but very long time ago.
Okay, have you seen this type of net explanation before? Or is this the first time? Manual
Yes,
net, auto
manual net are the first time service.
Okay. So, long time means before 8.3, we didn't have these things.
Okay.
8.3 itself is like 15 years old. So, now let us see static net first. See, this is the hierarchy in which the nets are executed. First, the manual net will be executed. If match is not found, it will execute the auto net section. If still match is not found, it will execute and do decision based on the after auto net. This is just showing the hierarchy. Now let us learn the types of net. We know that static net is one-to-one and it is bidirectional. Yeah, so publish internal server to a public IP, meaning we assign a public IP to the internal server in our organization so that people from outside can come in and we can also go out. No, this is not 100% right. Let me make it very clear for you. This is not that clear. We have a zone called DMZ in all our organization. We have a zone called DMZ. Now this is the zone where the public and the private meets. This is public. This is private. And this is common for both. That is DMZ, demilitarized zone. Now we got a server here. Why we call it a server? It is serving people inside the organization as well as outside. Maybe a web service, web server. You have your company's website. Both from inside and outside, they can log into this website to get some job done. Maybe ordering or looking into the catalog, whatever the company manufactures, they have posted there. So people from outside, they can order. Even from inside also, people can access the web server. So this is in, let's say, 172, which is a private range, subnetted network. So I got a server which need to serve the insiders as well as the outsiders, but in a private address. Or if I need to match the description given here in the document, I need to change this IP address to 192.10.
mm, mm,
So I have an address purchased called 203.0.113.10.
mm,
So whoever from the internet talks to this address,
mm.
they will be routed to this one by changing the destination IP. This is destination net.
Mm, mm,
Whoever comes to this address will come here. And whoever receives the response, they will be receiving from this address, because when the response go from here, the source gets translated,
mm,
and the IP address that the internet people will see is not the private but the public. So in that way, it is source net. So the reply packet will be source net.
mm,
The request packet is going to be the destination net in this case.
mm, mm, mm.
This is what we call as bidirectional net.
Yes.
So inside server is using a public IP address 203.0.113.10. What is the advantage? Advantage is we have written a policy saying any traffic coming from outside to DMZ, you need to be
Mm,
very strict.
mm,
But traffic coming from this inside to DMZ, not so strict, liberal,
mm,
and no NAT needed,
mm,
because it's coming from safe zone. This is one example.
mm,
But the example given here is not exactly what I said. Instead of DMZ, they use inside itself,
mm,
inside zone itself, instead
mm,
of DMZ. So let's come to this example now, and all I need to do is I need to remove this and change this as inside.
mm,
So we are creating an object first, saying object type is network type object.
mm,
There is another type called host.
mm,
Network object, host object. Here I'm saying network, give any name.
mm,
And then give the keyword host because it's single IP.
mm,
Single IP. Inside the object, still we are inside the object only. We did not go out. Inside the object, I am defining the NAT statement.
mm,
That's very important word to know. The difference between manual NAT and
mm,
auto NAT is this. We create an object. Inside the object, we define the NAT statement. What does this say? Any traffic coming from inside, which is this one,
mm.
inside zone, what we have? 192.168.10, isn't it?
Yes.
Going to outside zone, wherever he may go, doesn't matter,
Mm,
need to be natted, need to be changed. The source address need to be changed
mm,
statically. That's the method here, not dynamic,
mm,
statically,
mm, mm,
into this address. So we are saying if traffic is coming from inside zone with this particular IP address, going to the outside zone interface, doesn't matter where it goes, it
mm,
may go to 80.80.80.80 or
mm,
60.60.60.60, whatever the destination may be.
mm,
If it is going to the outside zone, then the source, the inside address need to be translated to this.
mm,
See, this outside is not talking about this one. This is not an outside address. This is the mapped address. But this inside here talks about
The host.
the original inside, which is defined here with host given.
Yeah.
So the NAT statement is well understood. It says if traffic is coming from this zone, going to this zone, with this address, and this address should come from inside only, not from any other zone. If matches, then the address need to be replaced with this. So so this is usually done whenever we are providing service to the public, like mail server or web server. Now I'm going to name this as inside. This is outside. And the address here I would like to give a public range. 203. 203.0. .10 I'll give here /24. The same subnet here I'm going to give .1. But for a static net I'm not going to use .1. I'm going to use .100. So whenever traffic comes from 192.168.1.100, I want to translate it to 203.13.0.13.10. Sorry, 13.100. Oh no. So this is my plan. So in this, what I'm trying to say is to use an address for mapping, that address need not to be there on any interface. Okay, now the address on the router side is 192.168.1.100. On the other side, the firewall side is .1. All right. So this is the plan. We can also have some destination like YouTube, Yahoo. So let's say this is 1.1.1.1 acting like an Yahoo server. Or no need on Yahoo. Yahoo, some network in the internet. And then I have 2.2.2.2/32. Fine. Now what is next is, let's quickly configure these things that we discussed. Host name inside. This need not to be inside. It can be any name. It is not on the firewall. But for our easy understanding, I'm naming it as in router. Okay. So host name is set. Now interface G000. It's 192.168.1.100, 255.255.255.0. This side is over. I don't have any other thing. I want to write just a default route pointing towards firewall. IP route, any just for the routing sake. Send it to 192.168.1.1. That's the address of the firewall inside interface. Now, show IP route. I don't have the route. The reason is the interface is down. Line protocol is down. Let us go to the firewall side. I'm going to say interface G1/1 and name if is the command inside. And then security level, because it's inside, we trust. So I give 100. Next is I put the IP address 192.168.1.100. Is the slash supported here? No, I need to type must. 255.255.255.0. Done. And wait a minute, let me give a host name firewall 1. Oh, it's not accepting. Okay, it didn't accept it underscore. Copy and start. Okay, so we have just given the IP address on one interface. Show name if, that's the command. Oh, it's not working in this simulator. No problem. Show IP interface. Show interface brief. Show interface IP brief. Yeah. Show interface IP brief is the command. We can see here G1/1 with the address, and it is up. Actually, in the real device, we have a command called show name if, that will be more friendly. Show route.
Same with FTD also, those syntax like creating a name if or show name if. Is it the same in FTD also?
I'm sorry, you are not audible. What is it you said, sir?
Okay, I was asking, is it the same syntax is used in FTD also, sir?
In command line, yes, in command line. But why you are working on command line? We don't work on command line there.
Okay, no, just to understand.
Commands are similar, yes.
Similar, okay.
We will be doing on GUI.
Okay.
IP address assigning, everything we do in GUI. But I just want to show you how the NAT objects and all work. When we create object, what exactly we are creating is what you will get a picture when I do it in CLI. Whatever I do in CLI, that gets done by you when you create objects in the GUI. So we no need to come to CLI. Okay, now interface G1/2, let me bring it up. Name if outside. Security level is set to default, which means least trusted interface. Security level 100 is high trusted. This is least trusted. Next is IP address. As we discussed, it is 203.0.13.1 255.255.255.0. Done. Now, even here, I would like to write static route, saying route, okay, IP route, IP route, any IP route outside
mm,
0.0.0.0.
mm,
Why it shows only IPv6? Okay, so don't start with IP. It thinks as we are writing as IPv6
mm,
starting route.
mm,
Without IP, we need to say
mm,
route via the outside zone interface,
mm,
traffic going to any. Now it shows IPv4.
mm, mm,
Any destination,
mm,
any net mask.
mm,
What is this? Okay, the gateway. The
mm,
gateway is 203.0.13. What address I gave on the other side? .10.
mm, mm.
Okay, now we are going to verify this. Show IP route. Show route. See, we got. Oh, okay. We have not finished the other router, so the line protocols are down. It shows only one router, which is inside. Let's finish the other router, then come and verify. I'll call it as out public. Interface G000. Put the IP address 203.0.13.10. Oh, okay. I put unnecessarily one dot here.
Yeah.
All right, now interface loopback 0 IP address. These are all testing networks.
Mm, mm,
Okay. So now if I ping from ASA firewall, I should be pinging those public. I'm pinging from here 2.2.2.2. I get a reply. I will get.
mm,
See, it's coming.
mm, mm,
So we got a basic routing.
mm,
Right now the packet is going from the source 200.
mm,
It is going with the source of 203.0.13.1 address.
mm,
Yeah. It's going with this public IP address, not the NAT address.
mm, mm,
How can I prove that? I can show you by debugging.
mm,
If you see debug
mm,
IP packets, and now when I go to firewall and try pinging,
mm.
there is some issue. I'm seeing some duplicate address. How is that? Show IP, show interface IP brief. What IP address I gave here is 192.168.1.0. It says inside also there's a duplicate address. What address I gave here? What is the plan actually? Okay, plan is .1 on the firewall, not 100. 100 is on the inside router. I made a mistake. So firewall inside interface name is gig 1/1, and then the IP address IP address is 192.168.1.1. Okay, that's why I should not ignore any of the complaints. It shows show copy run start. Okay, so now this error is gone. On the outside, I want to ping, not in the inside. On the outside, I want to debug, and then on the firewall, I want to ping and show you the source from where the traffic is coming. Hey, I don't know why this is behaving very. No problem. Okay, so let me ping once again. Ping 100.100.1, and I'll take you to the router where I enable debug. You can see it is coming from the WAN facing interface of the firewall, which is 203.13.10. Okay, this is not the one which we are going to use for netting. We will have 13.100, isn't it? That's what according to our plan. Fine. What is next? Right now, if I'll ping from here, if I'll ping from here to 1.1.1.1, the ping is not going for two reasons. One, I don't have, anyway, I have a default route. I don't have a policy allowing firewall. Even if the route is available, unless the policy is written, it won't allow the packet to pass through, isn't it? We need to write policy. We created zone, we put IPRs, everything is fine. Even this guy knows how to reach. You see, this knows how to reach 111, 222, and show route. Even we have a static default route here, but even here we have show IP route. But the ping won't happen. The reason is the policy is not allowing ICMP to pass through. Secondly, this guy do not know 192 network. Public will never know about 192. Why? That's a private reach. So only when you do natting, this will receive from 203. Unless natting is fixed, we cannot get the reachability. Yeah, so two things we need to fix first. Let us go and fix the policy thing. I'm going to quickly write one access list. This is like you write a policy saying permit ICMP in the GUI. You might have done that lab, or it may come later. You will be doing it. So we write a policy saying inside zone, outside zone, protocol ICMP, source any, destination any. That's what I'm going to do now. So I say access access list. Access list. I give a name. It's a ICMP policy permit ICMP any source, any destination. and then I say access list, sorry, access group ICMP-Paul in interface outside. Outside interface by default won't allow, I'm allowing it. I'm saying allow the traffic inside. Inside here is not the name of the interface. It is showing the direction. It shows that take inside. All those traffic coming on the outside interface. So if ICMP traffic is coming from outside, it will allow it inside. So policy is applied actually. Let us verify. Show access list. You can see oh no. You can see so far no hit count. Similar counter you will also see there in GUI. It will show how many hits have happened, how many packets are matched. ICMP traffic, if it is coming any to any, it should be permitted. Show access group. It's okay. We are binded to the outside. Now let us try pinging. Even now the ping won't happen. Even now if I ping, the ping won't happen for sure. I'm 100% sure. If you go here and check show access list, there is no hit count. The reason is right now the traffic is going from IP address 192.168, which is unroutable for R1. You see, there is no route for 192.
Yes.
When you debug IP packets, you can see the packet now coming here, but you see it's coming from 192, but the return traffic cannot go because you do not know the destination 192.168. Who is saying this? The public router is saying. For me, it's unroutable. So here, what do you understand? There is an IP path. What is left now is the NATing only. Everything is fixed. Only the NATing is missing. If NATing is there, this ping will happen. Now let us do NAT. What NAT we are going to do is static NAT. Before I do, I want to show you show NAT. Simple command, show NAT only. There is no NAT. Let's configure now. Object. Object. Network object. In the network object, you can specify a host or a subnet or a range of IP address. All these three you can do.
Okay.
Network object, I'm going to give a name. And the name will be nat-stat. And I'm going to say the host address is 192.168.0.100. Sorry, 1.100. The router's address. 1.100. Done. Now I need to say NAT statement. See, we are still inside the object. NAT can be written outside the object as well as inside the object. If you write inside the object, it is auto NAT. Okay? If you write inside the object, what we are doing is static NAT. In that, what category it is? Auto NAT category, which will be section 2. Manual NAT is section 1. We saw 3 hierarchy, right? Section 1 manual net, AutoNet section 2, and after AutoNet section 3. See, these things we need to know whether you are doing in CLI or Google GUI. You need to know because that is the order in which the execution is going to happen. When you are just writing one NAT, that doesn't matter. But when you write many different type of NAT, and you want some NAT to be executed first before the other, then you need to put it in right section. Okay. Now I'm saying NAT from where it is coming inside, comma, where it is going outside, static. If it shows like that, then I have made some mistake. NAT. Okay. Okay. Inside. Oh, it's not accepting. Comma. I need to simply. Oh, I need to put comma only. Okay. Now comes. I don't know why. Okay, maybe I didn't give space.
Space, okay. Yeah.
But it fills the space now. It gives automatically. Okay. Static.
Okay.
Dynamic NAT will come later. Static.
Okay.
So to which address we are planning to map it to? 100.
Yeah.
203.13 203.0.13 100. Now let us verify this. Show NAT. You see, it says if any traffic coming from inside, that's the source, going to outside, then I need to translate to this. And it is coming under section 2 AutoNet. You notice that?
Oh, okay. Got it. Yeah.
So far, no hit has happened, no translation has happened. Now let us go and ping from inside. It will ping this time. You see, it's pinging.
Yeah.
Now if you check here, first let us check the access list. It says there are 4 hits. So access list ICMP policy is matched. Secondly, the NAT should show the hit count, but NATing happened really. This is simulated. That's why I'm not able to see hit count, but I can show you here the traffic came from the NATed address. See? The destination, why it goes to that address? Because it was coming from that NATed address. Yeah? I'm able to see that NATing is happening. Yeah? So we have learned static NAT. And we have put the NAT statement inside the policy. So it has become what NAT? AutoNet. AutoNet position is section 2. Let's go back to the story. So you are comfortable with the AutoNet stuff. You are comfortable with static NAT, correct?
Yes.
Okay. So when you do in Gooby, it won't take this long. But you will not have that clear picture what we are doing if you skip this learning.
Yeah. Got it.
No. Also, why this is called as object NAT? Because we configured NAT statement inside object. I repeat, it doesn't mean that this one don't have an object. We will have an object, but we will not put the NAT inside the object. In Gooby also everything is object. We create object and we call it. You created the other day object I saw inside the name, or you selected one interface, you gave a name, you put it in an object only. Now let us go to the dynamic net.
mm,
Dynamic net is nothing but anyone can use one particular address,
mm,
which is also called as overloading. See, this is not the natting that we learned in router.
mm,
In router, we saw in CCNA, you might have learned like this:
mm,
static net, one to one.
mm,
Dynamic net is many to many, and
mm,
then pat is overloading.
mm,
Here you don't have that many to many dynamic net.
mm,
What it is many to many? If I have 100 computer,
mm.
in the address pool also I need to have 100 IP. Only then all 100 can
Translate.
simultaneously uh, communicate.
Mm,
If I have only 50 address here, all
mm,
100 cannot go online at the same time.
mm,
The other 50 have to wait for someone
mm,
to release the IP,
mm,
which is slow. So what we do, we overload. So it is not possible also to buy 50 public IP address.
mm, mm, mm,
It's not available even if we give money. So
mm,
we'll have very few, like one or two address in the pool.
mm, mm,
So what we can do is this 100 people can get overloaded using port number.
mm, mm,
So one port can support up to 65535
mm,
65,000. Let's take it as 65,000
mm,
mapping.
mm,
So you no need actually two IP address if you have only 100 employees.
mm,
Now what we see here in the dynamic net is this overloading story, including the port number. NAT is not just using the IP address for mapping, it is also mapping using port number. This dynamic NAT is not simply using the IP address for mapping, it also uses port number. So this dynamic NAT is same as PAT, which we learned in routing, in router class. Okay. So let us see this example. Okay, before that, this word is important. Multiple hosts share one public IP address.
mm,
In this example, we are going to see an inside subnet. Why subnet? Because multiple hosts. In one subnet, there are many hosts, right? Many IP addresses. And this is going to use one public IP address, which is already there on interface. See, it doesn't need to be an interface IP address. You can also give a different IP address if you have purchased. See, for static net, we did not use the interface IP. But for this, we use interface IP. You know why? Because this is dynamic net. We are not going to allow someone from outside to come in. It is only for insiders to go out and get the reply. So you don't need a dedicated address. See, in the previous case, if someone wants to talk from outside, they need one address. So we did not give the interface address, we gave a dedicated address so that people can use that address and talk to our firewall, and firewall will NAT it and take it to the web server. But here the requirement is not that. Here the requirement is simply to access the internet. See the first point, use case first point. User is accessing the internet, that's all. People from the organization, from inside, they are going outside to access the internet. There's no other service provided from inside to outside here. There is no service provided from our organization to outsiders. We are taking service from outside here. Correct, no? We don't provide, we take. So this is it. Easy, you see again. This is also AutoNet. Object. A subnet is given instead of a host. And all these are same. Instead of static, we say dynamic. And instead of IP address, we say use the interface IP. Shall we do this and see?
Yes,
Yes,
sir.
sir.
Okay. So what I'm going to do is, now I'm going to take many computers. Maybe I'll zoom out a bit. It's too big. Now I'll disconnect this cable from here and I'll bring some computers and switches.
Mm.
1, 2, 3, let's take. And a switch. Okay. Now there is no change on the router and the firewall. Here only it's just we need to add some computers with IP.
Mm.
I'm going to say here 192.168.1.100. So 100 is already given, 101.
Yes.
And the gateway is 192.168.1.1. That's the IP address on the firewall.
Mm.
Dot one. Okay, so this is done. What's up? Okay, this is given. Now likewise I go to the other two computers. Now we have the IP address ready.
Mm.
But if I ping now 1.1.1.1, the ping is not going to happen because we did not do natting for this address.
Mm.
What is this address here? 192.168.1.103. 103 we did not do any natting.
Mm.
We did natting only for 100, isn't it?
Yes. Yes.
For this 101, 102, 103, these three computers, we are going to do dynamic NAT. We are going to do dynamic NAT.
Mm.
Let's do this. So we are going to create another object, not the same object which we had earlier.
Mm.
Here, object, network. This is for dynamic NAT. And this time not the host command, inside the network command or
Mm. Mm.
subnet command.
Mm.
192.168.8. Is it 1? Yeah,
1.0.
1.1.0, correct.
Okay.
And the mask is 255. Let's try using the range command. Do we have range?
Mm.
We don't have a range here. Let me see host range. No. But in the real device, we also have a range command. We can say from this IP to that IP.
Yeah. Yeah.
192.168.1.0 subnet. Mask is 255.255.255.0. NAT. Same command. Inside, comma, outside. Outside dynamic interface IP is outside. You don't need to mention outside. You know why? Because here we have said outside. When the traffic is going out, so it understands that interface outside
Is outside
interface.
interface, right? Okay.
Now let us verify. Show NAT. You see, both are auto NAT, but the one which we wrote just now, the dynamic NAT comes on the top. So now, because we have said the entire subnet, this is one particular address. Sorry, for this we gave one particular address 192.168.1.100, but the entire subnet is matching on the top. So this is overshadowing this one. You understood?
Okay.
This will overshadow. Anyway, that's that thing we will discuss later. Overshadowing and all, shadowing.
Okay.
Now let us try pinging and debug. First, we will go and debug and see what address it is using now. Now I'm going to ping from here to check what address it is using. Is it using a mapped address or the static address or the dynamic pool? Okay, let's go to outside. It says it is still using the static address, so no problem.
100.
No problem. Now let us go to those computers.
So that means that static is most priority than the
Prioritize. So even
dynamic.
though the sequence is not, but the
Yeah, maybe because of some bug, I believe.
yeah. Now you see here, this is pinging, and now let us go and check. It is coming from one.
Yeah.
So that is the interface IP. Let's try pinging the other one 4444. Sorry, 2222. That's what exactly I want. Okay, I'll go to the other PC and ping 2222. Now also the traffic is coming from the same this to this. So dynamic NAT is also done. We have seen how to write static route and dynamic route using object. Now let us go back to our document. So this dynamic NAT is used only for internet. It uses ports dynamically. Now there is another NAT called many-to-many dynamic NAT. See, this is many to one address we are overloading. Many-to-many is like
Creating a range of
if I have
public address.
100 inside, then you need to give 100 mapped address.
Right.
Which is very difficult to do in the real world. You don't have that many address in the pool. Map inside host to the pool of public IP address. So here we are creating two separate objects. This one is the inside, and the another one is the outside, and using the range command. Here we are using the range command. Or you can also use subnet command. You see, in our simulator we don't have range command. I'll use subnet command. Again, it is less common today, as I said. You don't have that public IP address. And this is not done inside the object. This is called manual net. It's outside the object.
Okay.
Yeah, let's do this. Outside object. So no problem. I'm going to say object net, object network inside subnet 192.168.1.0 object, another object, say there is no range command, so I'm using subnet 200 dot 203. Done. We have two objects now. You see there I'm writing the NAT statement. I'm writing globally.
Okay.
Sorry, this simulator don't have the command. Okay, when we do that, it will be manual net actually.
Okay.
So
this manual
net
net
is
comes under section 1, right? So?
One.
Okay.
But after this name, if you add another name called AutoNet, another keyword called AutoNet, then it will go under the section 3. AutoNet is one keyword which will be coming after this. Okay. Don't worry, when we get the CLI, I will show you. Now, what is identity net? Identity net is you net to your own address. Meaning, some traffic you want to send it through the VPN without netting. But the problem is, netting is already enabled for that interface, but you want to escape from that net for those VPN traffics. See, traffic that must keep original IP address, meaning it should not get mapped.
Yeah.
So in that case, we can write identity net. How? You see, you create an object. You are inside the object. You are matching inside means what? It will match. It will match this one only, right? And you are translating to the same.
Oh, okay. Got. Okay.
You're calling the same object again. Easy,
And
right?
it's like 1-to-1 NAT. It will happen. So like 1.1 would be 1.1 statically. Okay.
Yeah, to its own address. If it is coming from A, it will get translated to A only. If it comes from X, it will get translated to X. Now, if you are doing that in the manual net fashion, you need to create objects separately. Only these 2 lines you will create. And then in the global mode, you will type this. And then you will say source static this. And then again, you will repeat this 2 times. That's it. And this is for destination. Destination, you don't need to worry.
Okay.
So, identity net, manually, if you want to do, this is the procedure. In the global mode, AutoNet, you want to keep it as, then this is the procedure. All right?
Okay. Yes, sir.
Next is policy-based netting. If that is nothing but destination net. Okay? So, only if traffic is going to that destination, that's the policy. Then netting should happen. Yeah? You understand, no? So, that is policy-based net. I think we will better do from here with the lab in our
Okay, sir.